Hello learners, welcome to our chemistry course at senior secondary level. We are planning to discuss lesson number 1, atoms, molecules and chemical arithmetic. We will discuss about Dalton's atomic theory, relationship between mass and number of particles, Avogadro's constant and its significance. Also discuss mole mass and number relationship, molar volume etc. during this program. We have with us Dr. Sulekh Chandra, Associate Professor, Zakir Hussain College, University of Delhi for this discussion. Welcome to our program, sir.
Now I will discuss atoms, molecules, and I also explain the importance of chemistry in daily life. Now first of all I will explain what is chemistry actually. Chemistry is you can simply say, the matter and the changes it undergoes. Chemistry is often called the central science because a basic knowledge of chemistry is essential for the study of biology, physics, geology, ecology and many other subjects. Chemistry plays a vital role in many areas of science and technology, for example, in health, medicine, energy, environment, food, agriculture and new materials. I think you are familiar that we talk about the chemistry in the medicine. You are very well aware that cisplatin is used to treat the cancer. Similarly, if you inhale mercury, then EDTA will be used as an antidote of mercury. So you can simply say in agriculture you are very well aware that we use number of fertilizers to grow up the crop. Without fertilizer you cannot get the good quality or quantity of the crop. So in nutshell we can say the chemistry plays a vital role in each and everyday life. So in this topic, or you can say in this lesson, or you will be able to understand, explain the scope of chemistry, explain the atomic theory of matter, state the laws of chemical combination, explain Dalton's atomic theory, that is Dalton atomic theory, define the terms element, atoms and molecules, state the need of SI units, explain the relationship between mass and number of particles, define Avogadro constant and states its significance, calculate the molar mass of different elements and compounds. Now first of all, scope of chemistry. Chemistry that I told you earlier also, that health and medicine, energy and environment, material and technology, food and agriculture. Particle nature of matter. Chemistry deal with the study of structure and composition of matter. Since ancient time, people have been working about the nature of matter. Suppose we take a piece of rock and start breaking it into smaller and smaller particles. Can this progress go on forever, resulting in smaller and smaller particles, or would it come to stop when each particles are formed, which can no longer be broken into smaller particles? Now laws of chemical combinations. You are very aware that laws of different laws of combination given by Dalton's. In every chemical reactions, total masses of all the reactants is equal to the masses of all the products. This law is known as law of conservation of mass given by Lavoisier. Now if you suppose you take a reaction Mg plus O2, the formation of 2MgO, so we can say 2Mg plus O2 to give you 2MgO. If you calculate the reactant mass of reactants and mass of products, you will find that will be the same, which indicates that in a chemical reactions mass will not be destroyed. It will be always conserved. Means you can say mass of the products and reactants will remain same. Now Proust demonstrated the fundamental law of definite constant proportions in 1808. In a given chemical compound, the proportions by mass of the elements that compose it are fixed, independent of the origin of the compound on its mode of preparation. So you can simply say, suppose you take water molecule, either you can prepare by reaction with H2 plus O2, or you can collect the water from any source. You will find there is a constant proportion of hydrogen and oxygen in the water. So this is called as constant proportions. In pure water, for example, for instance, the ratio masses of hydrogen to the mass of oxygen is always 1:2. or you can say mass will be 1:8, irrespective of the source of water. In other words, pure water contains 11.11% of hydrogen and 88.89% of oxygen by mass, whether water is obtained from well, river or from a pond. Thus, if 9 gram of water are decomposed, 1 gram of hydrogen and 8 gram oxygens are always obtained. Dalton's atomic theory, which is important because in the beginning Dalton has given atomic theory. The postulates of Dalton atomic theory are: number 1, matter consists of individual atoms. All the atoms of a given chemical element are identical in mass and in all other properties. Different chemical elements have different kinds of atoms, and in particular such atoms have different masses. Atoms are indestructible and retain their identity in chemical reactions. The formation of compound from the elements occurs through the combination of atoms of unlike elements in a small whole number ratio. Atoms are not indivisible. They can be broken down into smaller particles, although they lose their chemical identity in this process. But in spite of all these developments, atoms still remains a building block of the matter. Now, how do you explain molecules? A molecule is an aggregate of at least 2 atoms in a definite arrangement held together by chemical forces called, you simply say, chemical bonds. It is the smallest particle of matter, an element or a compound which can exist independently. So, we can differentiate between atom and molecule in a simple way. The atoms does not have independent existence, but when 2 or more atoms combine together, they form a molecule which have independent existence. Elements we can define. An element is a substance that cannot be separated into simpler substances by chemical means. It is, well, you can say to date 118 elements have been positively identified. 83 of them occur naturally on the earth. The other have been created by the scientists via nuclear processes. Now, before moving further, you should be clear about the SI units, because nowadays only SI units are used. For example, you can take length, we can take meter. So, measurement is needed in every walk of life. As you know that for every measurement, a unit or a reference standard is required. In different countries, different system of units gradually developed. In 1960, the General Conference of Weights and Measures, the International Authority on Units, proposed a new system which was based upon the metric system. This system is called the International System of Units, which is abbreviated as SI unit. The given unit SI units are, you will find here, although you have already studied these SI units in secondary level, but you should be clear. The length is a meter, abbreviated as small m, mass kilogram, kg, time second, etc. Now, we can say here relationship between mass and the number of particles. Suppose you want to purchase 500 screws, how do you think the shopkeeper would give you the desired quantity? By counting the screws individually? No, because it is not possible. If he is supposed to start counting 500 screws, then it will take a lot of time. He would give the screws by weight because it will take a lot of time to count them. If each screw weigh 0.8 gram, he would weigh 400 gram screws, but it is the mass of 500 screws, that is 0.8 gram into 500, you will get 400 gram. Thus, we see that mass and number of identical objects or particles are interrelated. Since atoms and molecules are extremely tiny particles, it is impossible to weigh or count them individually. Therefore, we need a relationship between the mass and the number of atoms and molecules particles. Such a relationship is provided by mole concept. Now, what is mole concept? Mole is the number of unit mass of an atom or a molecule is an important property. However, while discussing the quantitative aspects of a chemical reaction, the number of reacting atoms or molecules is more significant than their masses. A mole is the amount of the substance that contains as many as elementary entities, atoms, molecules, or other particles as there are atoms in each 0.012 kg or 12 gram of the carbon 12 isotopes. A mole is substance, that is Avogadro constant. A mole is substance is the amount which contains as mass elementary entities as there are atoms in exactly 0.012 kilogram or 12 gram of carbon, that is 12 isotopes. This definition gives us a method by which we can find out the amount of substance in moles if we know the number of elementary entities present in it or vice versa. Now the question arises, how many atoms are there in exactly 12 gram of carbon or carbon 12? This number is determined experimentally and its currently accepted value is 6.022045 into 10 to the power 23. Thus, a mole will be equal to 6.022045 into 10 to the power 23 entities or particles or atoms or molecules named off to 6.022 into 10 to the power 23. So, this is called actually Avogadro constant. Now, what is the significance of Avogadro constant? As we know, 0.012 kg or 12 gram of carbon 12 contains 1 mole of carbon atoms. When we say 1 mole of carbon 12, we means 6.022 into 10 to the power 23 atoms of carbon 12 whose mass is exactly 12 gram. This mass is called molar mass of carbon 12. Though molar mass is defined as the mass in gram of a 1 mole of substance, similarly a mole of any substance would contain 6.022 into 10 to the power 23 particles or elementary entities. The nature of elementary entity however depends upon the nature of the substance as given here. You will find here that elements like sodium, potassium, copper which exist in atomic form, elements like O and H which exist in molecular form O2, N2, H2, molecular compounds like ammonia, H2O and CH4, ions like Na+, CO2+, Ag+, Cl-, O2-, ionic compounds like NaCl, NNO3, K2, SO4. So for you can elements के लिए आप atom use कर सकते हो, element entity. Elements like that is molecule के लिए आप molecule कहते हैं हम उनको. Then molecules, then having charge come category of ions, and the compounds we calculate this formula unit. Atoms or ions of different types are given here as chemical formula of the following example would clarify the concept. So you can simply say this is H2O, 2 atoms of H and 1 atom of oxygen, NH3, 1 atom of N, 3 atom of hydrogen, NaCl, 1 atom of Na+ and 1 atom Cl-, and this is the ions. Similarly, 1 ion of NNO3, 1 ion of Na+ and 1 ion of NO3- ion. K2SO4, you can say 2 K plus ion and 1 SO4 ion. Ba3PO4 whole twice, 3 Ba plus ion and 2 phosphate ions. This is you can say mole mass and number relationship. Atomic mass unit. The atomic mass unit is defined as mass exactly equal to the 1/12 of the mass of the 1 carbon 12 atom. That is you can say 1 AMU, that is atomic mass unit, will be equal to mass of 1 C12 atom divided by 12. Now relationship, relative masses of atoms and molecules are the number of times each atom or molecule is heavier than 1/12 the mass of the 1 carbon 12 atom. Often we deal with elements and compounds containing isotopes of different elements. Therefore, we prefer to the average masses of the atoms and molecules. Thus, we can say the relative atomic mass will be equal to average mass of one atom of the elements divided by 1/12 of the mass of the one carbon 12 atom, and relative molecular mass, average mass of the molecule of the substance divided by 1/12 of the mass of the one carbon 12 atom. Now, atom, molecules and formula masses. From the definition of atomic mass unit, we calculate the atomic masses. Let us again take the example of oxygen 16, whose relative atomic mass is by 16. By definition, we can say relative atomic mass O16 will be 16 is equal to mass of O16 atom divided by 1/12 of mass of the carbon atom. Since 1 AMU is equal to 1/12 mass of the carbon 12 atoms, so 16 will be equal to mass of 16 O atom divided by 1 AMU. So, you can say mass of O16 atom will be 16 AMU, atomic mass of O16 will be 16 AMU. Example, you can calculate the molecular mass of ammonia, for example. So, you should be clear here what is the molar mass of this. You can say atomic mass of nitrogen and atomic mass of hydrogen. So, you can say one molecule of ammonia consists of one atom of nitrogen and 3 atom of hydrogen. So, molecular mass you can calculate, that is the atomic mass of nitrogen, that is 14, and there are 3 hydrogen, that is 3 into 1 3, 14 plus 3 is equal to 17 AMU. Similarly, suppose we take potassium nitrate. Now, in case of potassium nitrate, potassium atomic mass is 39, nitrogen 1, that is 14, then there are 3 oxygen, 16 into 3, that is 48. So, you can add 39 plus 14, that is 53, plus 48. So, you can find 101. Now, molar mass, we know that molar mass is a mass of 1 mole of the substance. Also, 1 mole of any substance is the collection of its 6.022 into 10 power 23 elementary entities. Thus, molar mass will be equal to mass of 6.022 into 10 to the power 23 elementary entities. Molar mass of an element, you know that relative atomic mass of the carbon 12 is 12. A 12 sample of it would contain 6.022 into 10 to the power 23 atoms. Hence, the molar mass of carbon 12 is 12 gram per mole. For getting the molar mass of other elements, we use the relative atomic masses. The elementary entities in case of molecular substance is the molecule. Hence, molar mass of such a substance would be mass of its 6.022 into 10 power 23 molecules, which can be obtained from its relative molecular mass or by multiplying the molar mass of each element by the number of its moles present in 1 mole of the substance and then adding them. Now, let us take one example here, that is water. Its relative molecular mass is 18. Therefore, 18 gram of it would contain 6.022 into 10 power 23 molecules. Hence, its molar mass is 12 gram per mole. Alternatively, we can calculate it. Molar mass of water, that is H2O, 2 into molar mass of H, molar mass of O, you will get, that is 2 into 1, then 16, 18 gram per mole. Now, molar mass of an ionic compounds. Molar mass of ionic compounds is the mass of its 6.022 into 10 to the power 23 formula units. It can be obtained by adding the molar masses of one present in the formula unit of the substance. In case of NaCl, it is calculated H. Molar mass of NaCl will be equal to molar mass of Na plus ion plus molar mass of Cl minus ion. So, I think you are very well aware that molar mass of sodium is 23 and Cl is 35.5. We have to add them, we will get 58.5 gram per mole. Now, calculate the molar mass of K2SO4. Molar mass of K2SO4 you can calculate 2 into molar mass of K plus ion plus molar mass of 2 sulfate 2 minus ion. 2 into molar mass of K plus molar mass of sulfate, that is you can simply say 2 into 39.1 for potassium, 32.1 into 4 into 16, you will get total amount, this is you can say 78.2 plus 32.1 plus 64, you will get 174.3 gram per mole. Now example, find out the mass of carbon 12 that would contains 1.0 into 10 to the power 19 carbon 12 atoms. Mass of 6.022 into 10 to the power 23 carbon 12 atoms is equal to 12 gram. Mass of 1.0 into 10 to the power 19 carbon 12 atoms will be equal to 12 into 1 into 10 to the power 19 divided by 6.022 into 10 to the power 23, that is equal to 1.99 into 10 to the power minus 4 gram.
Thank you, sir, for sharing such a details about atoms and molecules. Learners, now the time for what you have learned during this discussion. I would like to sum up in few points in the form of what you have learned, or you can say recapitulate. Chemistry plays an important role in many aspects of our life like health and medicine, energy and environment, materials and technology, food and agriculture, etc. The law of conservation of mass. In any chemical reaction, the total mass of all the reactant is equal to the total mass of all the products. In a chemical compound, the proportions by mass of the element that compose it are fixed and independent of the origin of the compound or its mode of preparation, that is law of definite proportion. When two elements form two or more compounds, the masses of one element that combine with a fixed mass of the other element are in the ratio of small whole numbers, that is the law of multiple proportions. John Dalton gave the atomic theory in which he proposed that it is the smallest indivisible particle of matter. Atoms of the same element are all identical, while atoms of different elements differ. Atoms of different elements combine in a simple whole number ratio to form a molecule. An atom is the smallest particle of an element that retains in its chemical properties. A molecule is the smallest particle of matter which can exist independently. An element is a substance that cannot be separated from simpler substances by chemical means. Mole is the amount of a substance which contains as many elementary entities as there are atoms present in 0.012 kg or 12 gram of carbon 12. Thus, mole denotes a number. The number of elementary entities present in 1 mole of a substance is 6.022 into 10 to the power 23. The mass of 1 mole of a substance is called its molar mass. It is numerically equal to relative atomic mass or relative molecular mass expressed in grams per mole or kilogram per mole. Molar volume is the volume occupied by 1 mole of a substance. 1 mole of an ideal gas at standard pressure and temperature, that is STP 273 K and 1 bar, occupies 22.7 liters. Thank you.
घर बैठे पाएं राष्ट्रीय मुक्त विद्यालय शिक्षा संस्थान यानी NIOS में एडमिशन, वो भी एकदम आसान तरीके से, जिससे शिक्षार्थियों को होगी समय और धन दोनों की बचत। NIOS से शिक्षा कभी भी कहीं भी। शिक्षार्थियों, क्या आप जानते हैं NIOS में एडमिशन लेने का सरल और सुगम तरीका, जिससे शिक्षार्थियों को ऑनलाइन प्रवेश लेने में सहूलियत मिलती है। NIOS में प्रवेश की प्रक्रिया पूर्णतया ऑनलाइन है। शिक्षार्थी घर बैठे इंटरनेट द्वारा प्रवेश के लिए सबसे पहले NIOS की वेबसाइट www.nios.ac.in पर लॉगिन करें। अपना ईमेल आईडी और पासवर्ड डालकर अपना पंजीकरण करें। पंजीकरण के बाद लॉगिन करने पर ऑनलाइन प्रवेश हेतु आवेदन पत्र खुलेगा। आवेदन पत्र को निर्देशानुसार भरें और प्रिंट आउट लें। इस प्रिंट आउट पर अपनी फोटो संलग्न करें। ऑनलाइन प्रवेश के लिए शुल्क हेतु भुगतान के तरीके हैं: क्रेडिट कार्ड के द्वारा, डेबिट कार्ड के द्वारा, राष्ट्रीयकृत बैंक के ड्राफ्ट के माध्यम से, जो कि सचिव NIOS नई दिल्ली या नोएडा के पक्ष में देय हो। भरे हुए आवेदन पत्र के साथ साथ डिमांड ड्राफ्ट और संलग्न किए जाने वाले दस्तावेज हैं: जन्म रजिस्ट्रार के जिला कार्यालय से जारी जन्म प्रमाण पत्र की सत्यापित प्रति, जिसमें जन्म तिथि अंकित हो, पिछले विद्यालय से प्राप्त विद्यालय छोड़ने का प्रमाण पत्र, जिसमें आवेदक की जन्म तिथि लिखी हो। प्रवेश फॉर्म का प्रिंट आउट NIOS के संबद्ध क्षेत्रीय केंद्रों पर 10 दिनों में पहुंच जाना चाहिए, अन्यथा उचित दस्तावेज ना लगे होने पर आवेदन फॉर्म रद्द किया जा सकता है। प्रवेश प्रक्रिया की पुष्टि होने के बाद शिक्षार्थियों को परिचय पत्र व अध्ययन सामग्री डाक द्वारा तुरंत पहुंचाई जाती है। ऑनलाइन प्रवेश एक बहुत ही सुगम और सुविधाजनक प्रवेश प्रणाली है। ऑनलाइन ऑन टाइम फॉर सेफ एंड सिक्योर एडमिशन।
करने राहों को आलोकित करने, जीवन ये प्रकाशित करने राहों को आलोकित करने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने, हम अपना दीपक स्वयं बने, हम अपना जीवन ये प्रकाशित करने राहों को आलोकित करने। धन साधन समय की सीमा से विद्यालय जो मुक्त हो, कभी पढ़े हम कहीं पढ़े वे विषय की लोच से,